The start? 1, 2, 3, nothing? Okay. What's the time now? Yeah. Very good afternoon, everybody. So this is Dr. Ramachandra, Associate Professor and Research Director for Crystal Growth and Nanoscience Research Center, Government College Autonomous, Rajahmundry, Andhra Pradesh, India. So today I would like to explain a world gigantic experiment, and every physics student should know about this particular theory and as well as experiment. The theory is Big Bang theory. What the name is it? Big Bang theory. And did you remember or not, I don't know, but during 2009 and 10, in those years, almost all population of the world was sitting or was stick to TVs, because there was an announcement came through televisions that this world is going to end up by today or tomorrow or within a short time, because the world gigantic experiment is going to initiate it, and out of that there is something is going to be happen. So that particular experiment will destroy this entire world. That was the news telecasted in the TVs. So everybody got scared about this particular news, because we don't have life next day onwards, means definitely everybody from child to grandma, grandparents, everybody got lot of fear and as well as tension. Everything will come into the mind. So what was the reason? Being a physics student, you must know what was the reason for this particular alarming to the humans of this world, and what is happening in this universe, that you should know. So particularly there is a theory. The theory is Big Bang theory. This Big Bang theory secrets of this universe. So all the world topmost renowned scientists searching for the secrets of this universe. Okay, still we have lot of unsolved questions in this universe. I want to say one thing. What you are seeing in this universe is only 10 to 20%. What you are not able to see is 80%. So that means 80% of this universe you are not able to see. Why? How can you assess this? And only your visible universe is only 10 to 20%. It's a big question. How we are, so we have a technology. So the humans are going to celestial bodies, and we are planning to construct some space colonies on moon and other planets. But even if we are able to see this universe only 10 to 20%, and remaining we are not able to see. Why? What is the reason? And that is the first question. And the next question is, we have matter. The matter is combination of electrons, protons, neutrons. Up to now only we have known these things, but not only this, pion, muon, kaon, lepton, barons, tau, many many elementary particles are there in this matter. So do we have a standard model to classify all these elementary particles which are available in this universe? No, we don't have the standard model. And one more thing is, you might have heard this word, dark energy, dark matter. So this dark energy, dark matter is nearly 72% dark energy, dark matter is there in this universe. We don't have a specific understanding of this dark energy, dark matter. This is also an unsolved question. And the next question is, first of all, we are living on this beautiful blue planet and we are seeing this wonderful universe, and then do we have ever think of that, so what is the age of this universe? Then do we have any formulas for this? These are all unresolved and interested questions. Understand? These are all unresolved. Why I am saying it is unresolved? So the scientists are striving still to know about these questions. These are very curiosity questions. We are able to see only 10 to 20% in this universe. So what about other 80%? And then we have n number of elementary particles, but we don't have standard model. And then how can we know the age of this universe? What are the early conditions of this universe? So suppose, do you know or not, but one more information I would like to give about this universe. The universe is still in expanding mode. We are in traveling mode. You believe me, we are in traveling mode. We don't know whenever it is compressing back, whenever it is stopped. We don't know. So this is also a curiosity question for the human beings to learn about this. So that's why there is many scientists have come with different theories about our universe, to know our universe, to know the secrets in this universe. Then one of the theories, a popular and evidented almost theory, is Big Bang theory. Big Bang theory. So the name itself, it will give you Big Bang. So there is some bang, there is some explosion, there is some bomb, there is a booming sound. So when the universe is going to start with this universe with a bang. So there is an evidence for this particular theory. Okay, so let me give you, let me sensitize you, let me enlighten you some of the topics or some of the contents about this Big Bang theory and our universe, and some of unresolved questions, why and where and how we learn about these things. Okay, so let me go forward this. So Big Bang, you just see on the screen, it's a Big Bang. So Big Bang was happened, and these are the questions, these are the curiosity questions. How and when did the universe form? Do you have any evidence? And how the solar system and Earth form? And what is the age of a moon? The moon is a natural satellite of Earth. Okay, these are the questions. And then what are the early Earth conditions? When it forms, then everything is matter. And then when Earth forms, then what is the conditions? What are the conditions? How do we know? So these are the questions. How do we know? But it is a responsibility of the scientists to know about this. A researcher, scientist, some curiosity humans, they should know about this, how the universe is formed, and then what are the early conditions of Earth, and what are how the solar system and Earth form, and how the moon form. So these are all the things. Then let me tell you one fact that Big Bang, a bang was happened 15 billion years back. 15 billion years back, a bang was happened, and that is a model for beginning of the universe. This is a theory. See, theory, the scientists have an imaginating power, and the scientists or those who are world popular personalities, they have the imaginating power. Okay, so recently, last year only came that about the gravity waves, the Newton, not Newton, Einstein. The Einstein was theoretically explained the origin of the gravity waves, but in 2018, I guess, in 1908 or 1905 to 1908, he proposed the theory there were some gravity waves, but the scientists do not believe on this particular issue. But after 100 years, 120 years, the scientists proved that there were gravity waves. Understand? So that is the imaginating power of the Albert Einstein. Like that, everybody, that means the scientists have an imaginary power. So by that imaginary powers, they come with a proposal of a theory. The theory is proved with a experimental evidence, then the theory is coming to the realization, and we should all follow that particular theory and as well as practical. See, being a science students, so we are learning theory in the classroom and in a laboratory, what we learn in the theory class, and we are going to have an experience, hands-on experience with the laboratory equipment and experiments. Understand? So like that, the theory is there. The theory proposed by different scientists, they believed that 15 billion years back there were a big bang that was the origin of this universe. Understand? So then the next question is, how come, how do they come with a conclusion of 15 billion years ago? This is the first question. And then, so what they expected, what the theory is telling you is, an infinitesimally dense point not governed by our physical laws or time, all matter and energy contained in one point. This was the expectation. All matter and energy. In this universe, everything is matter and in the form of matter and energy. So the matter and energy contained in one point, that point is not explained by our existing physical laws. It is above our physical laws. Understand? An infinitely dense point, high dense point, not governed by our physical laws, and also in that particular point, the whole matter and energy contained at one particular point. Then now, that point is, you just see a small dot. It's the small dot. And the next, here I would like to tell you one thing. There is a big explosion. What is the reason for this explosion? The point itself, it won't expose, it won't break, or it won't combine. Explosion means that something might be happened inside that dense point. What the something? See, for suppose if you have a positive and negative in battery, you have a positive and negative. When you just connect this battery one end and another end with some wires and put these two wires contact together, then what is going to happen? You can see the fire. Understand? So that means the positive and negative, whenever it happens to combine, then automatically there is an inhalation process. Then these inhale that thing, and then you might have seen some sparkles around that. Correct? So like that here, the reason for this big explosion is the matter and antimatter. What is that? The matter and antimatter. See, the matter and antimatter is, the matter and antimatter means one is a positive and another is a negative. Whenever it is combined, there is a annihilation process. Annihilation. There is a matter and antimatter. Whenever it combines, there must be some annihilation process. Annihilation process means a big fire is going to be come out of that. But here the point how the scientist, and that means the scientist idea is here, there is a matter and as well as antimatter. There is a matter and antimatter, but they are in unequal amounts. If it is an equal amount, the total is going to be disappear whenever it combines. One is a matter and it is an antimatter. So matter and antimatter, if they are equal amounts, then if you combine them, then totally it is come in the form of energy. Energy, nothing is left. If matter and antimatter are equal amounts, if matter and antimatter is an equal amount, then they combine, then nothing will left. But here, what the scientists they expected, the matter and antimatter is there, unequal parts of matter and antimatter. Unequal part means one is somewhat higher and somewhat lower. They are not equal. If it is unequal matter and antimatter, they combine, means annihilation process is there. A big explosion is there. If big explosion happens, then the matter equal to antimatter, almost all it is comes out in the form of energy, and the part, sum of unequal means some part is left. The left part is our universe now. Understand? That is the concept. There is an unequal amount of matter and antimatter, they combine each other, and matter and antimatter, if they equal, there is a big energy comes out of it, and what the unequal amount which is left, the left part is our universe. Understand? So then, now I am taking you to when time t equal to 0. Now time t equal to 15 billion years. When time t equal to 0, what was happened at that time? So matter and antimatter, there are unequal amounts, they combine each other, then unequal means the equal amount comes out in the form of energy, that unequal part is left, that is a existing universe. Then now you just see the creation of this. This is a Big Bang theory. When you are looking at time t equal to 0, this is a time part, at time t equal to 0. And then time t equal to 10 power minus 20 minus 43 seconds, minus 32 seconds, minus 6 seconds, 3 minutes after big explosion. Then now 3 lakh years, now 1 billion years, and then 15 billion years. Now it is present day. Now let me explain how this universe is expanding and how it is from. So one big explosion comes out now, then big explosion comes out, then the part which is going in all the directions. So 15 billion years back this was happened. The evidence for this is still, if you are observing some telescope, I will name it after some time. So still we are in expanding mode. That was happened 15 billion years. Yes, in almost all the directions the universe is expanding now. So let me explain at time t equal to 0 what is happened. See, time t equal to 0, there were a big explosion, and then see, then 10 to the power of minus 43 seconds, gravity separate from other forces. We have 4 forces, you know that. What is that? Electric, weak force, strong force, gravity force, electromagnetic force. So that means after explosion was happened at time t equal to 0 to t equal to 10 power minus 43 seconds, then gravity separates from other forces 10 to the power of minus 28 centimeters. What is the size of that? 10 to the power of minus 28 centimeters. And then 10 to the power of minus 35 to 10 to the power of minus 32 seconds after that, after minus 43, then fundamental particles like quarks and electrons softball at this time t equal to 0 to t equal to 10 to the power minus 35, then fundamental particles like quarks and electrons, they combine like a softball. What is the size? You just imagine it. And 10 to the power of minus 6, quarks combine into proton and neutron, then solar system. See, the matter is nothing, matter if you go inside molecules and then atom and then nucleus and inside the proton and neutron around that electrons, and the proton is not a proton and neutron is not a neutron, the proton is a combination of quarks, so that means 2 up quarks, 1 down quark proton, and 2 down quarks, 1 up quark neutron. So that is the quarks. The quark is the matter, quark is a matter in the form of protons and neutrons. It forms your nucleus. Understand? So that is a part. So at 10 to the power of minus 6 seconds, quarks combine into protons and neutrons, the solar system started to form. And then at 1 second, after explosion of 1 second, what is happened here? Then electromagnetic and weak nuclear forces are separate. First gravity, that is the weakest force. Okay, so gravity force, and then electromagnetic and weak nuclear forces are separated. Then after 3 minutes, what was happened? Protons and neutrons combine into atomic nuclei after explosion, and then after when atomic nuclei forms, okay, atomic nuclei forms, after 3 minutes after, it takes 10 power 5 years. 10 power 5 years, the electron join nuclei to make atoms, and light is emitted. When atom is formed, then only there is a possibility to get light. Understand or not? To get light. So that means 10 power 5 years, it needs 3 minutes to 10 power 5 years, it needs that much of time gap is needed to form or to join electrons with a nuclei. When electron joins with a nuclei, then atoms will form. So that means a group of atoms is nothing but a molecule, then it is a matter. So when the atoms are formed, then only we have a light. So that means the light, how the light is comes means, so when the atom is excited, then the electrons will go to from lower energy to higher energy. Whenever it falls down from higher energy to lower energy, it is formed in the form of light. So how the tube light is function means, so that's a simple story. When the positive and negative are there, then these are gives out some kind of photons, and this interacts with molecules or inert gas is there inside the tube, and then this again goes to excited state. While coming to the ground state, it will gives you light, and that light is interact with the fluorescent screen over this tube, and then you will have a light. So this a lot of physics is there in tube lighting. Like that, so we after 10 power 5 years we have a source of light when the Big Bang formed, and 10 power 5 to 10 power 9 years matter collapses into clouds making galaxies and stars. Understand? So 10 power 5, how much time it needs? 10 power 5 to 10 power 9, then the matter collapses into clouds and then making galaxies and stars. And then now, this is a nutshell, you just see, it is a nutshell. Big Bang was happened here, and then different stages, now we are here. In a nutshell, there are different stages. It is still in expanding mode. Now our position is here now. Then you may ask one question here. Sir, how can you say the universe is still expanding mode? How can you say that the universe is still expanding mode? There is an evidence. The scientists don't speak without evidences. It is not a superstition. It is a real science. Okay, so that means I am saying you, it is a past and now it is present and the future may be like this. We don't know what is going to happen in the future, but still now it is in an expanding mode. Okay, in a nutshell, that's the universe. We see an expanding collection of galaxies emerging from a hot dense phase point 14 billion years ago. Let's think more carefully about the stuff that stars and galaxies are made of. It's a time to think. So that's why the space science is very, very interesting science. The space science means in Andhra University, MSc Space Science is there, Space Physics is there, and Usmania University. Today, if you go through Hardon newspaper, Usmania University professor has given a lot of opportunities or opening for MSc Space Physics students. So one of these topic. Okay, let me tell you the other things. And then now, we have Hubble telescope. Edwin Hubble telescope, it is a gigantic telescope in the world, and this telescope gives you the secrets of Big Bang, or I can say some of the evidence for this hypothesis. So these are the hypotheses, these are the assumptions, these are the imaginary things about our universe. So that means the universe has started with a small point and 10 to the power minus 43 seconds, 10 to the power minus 32 seconds, 10 to 1 second and 3 minutes, and then 10 power 5 years and 10 power 9 years, and then now it is 14 billion years. These are all expectations, or imaginations, or hypotheses, or assumptions. And then do we have any evidence for this assumption? Yes, we have. Yes, we have. That evidence is Hubble, that evidences or the secrecies or the imagination, these hypotheses can be supported with a Edwin Hubble telescope. Okay, then now universe is still continuously expanding. The universe, the first point is the universe is still continuously expanding. And the second one is galaxies' velocity is proportional to the distance. Galaxies that are twice as far as from move twice as fast. See, this is the evidence. This is the evidence to calculate the age of this universe. This is the evidence that the galaxies or the universe is still in expanding mode. So that means the Hubble telescope is there with us. The Hubble telescope, when you are observing this universe continuously, what the scientists are observed, what are the facts. So that when they are observing this universe, galaxies are moving away from our Earth. We are in Earth, that means Earth may be in expanding mode and moving away from that particular starting point. Understand? But when you are seeing galaxies from our Earth, and then these galaxies are moving away. Almost all, we are in the Earth at the center, and then if you are seeing these galaxies are moving this direction, and these galaxies and this direction, almost all the directions they are moving away. Suppose if that means the scientists are able to calculate in the form of light years the distance, and then from this year to next year the galaxies are moving away. So that we call it as a red shift. So according to Doppler effect, we can calculate how much far they are going, how much velocity they are taking away from our Earth. So that means the Hubble telescope give you the evidence. So that means the galaxy position, if you see in the 2018 year and 2019 year, they are moving away. That means we are able to see exactly how this, and taken every galaxy the same amount of time to move from a common starting point from its current position. See, the galaxy is moving from this point and this point and this point over that. It's like a circle. If you form the galaxies on this particular circle, they are moving almost all equal distance from this starting point. Understand? So suppose only one galaxy is moving, then you can't assess that the universe is expanding more. So in almost all the galaxies which you are observing through Hubble telescope in all the directions, and they are moving away from this. That means the universe is continuously expanding. By using this particular property, by using this particular concept, the scientists are able to calculate the age of the universe. Once you know how much distance they travel, we have an imaginating power. So if in this particular time, this much of distance, if it is moving away, then so we can expect when time t equal to 0 and what is the position and how much time will it take from that position to this position, and we are able to calculate. So I will tell you a simple thing. So this is the Hubble evidences. That is what we call it as the Doppler shifting. Okay. And one more thing is the wavelength which comes out from these galaxies, they are moving away from us. They are shifted to lower frequency side. So that means the galaxies, we are receiving some kind of waves. The wavelength is emitted from these galaxies. They are diverting towards lower wavelength side. Understand? So that means that is a Doppler shifting. So because of this particular thing, we are able to calculate. That's what we call it as a redshift. And then now let me tell you about this redshift. So in 1964, Arno Penzias and Robert Wilson discovered a noise of extraterrestrial origin that came from all the distance at once. Understand? That is the radiation left over from the Big Bang. See, that is an evidence. They observed that in 1964, Arno Penzias and Robert Wilson, they discovered a noise of extraterrestrial origin that came from all the directions at once. That is the radiation left over from the Big Bang. So when the Big Bang was happened, I already pointed out that, so unequal amount of matter and antimatter, they combine each other. There is the unequal amount means equal amounts they form in the kind of radiation or energy, and unequal part is left, that is the university which you are seeing now. So that means this matter and antimatter inhalation, then you have an energy, that energy in the form of radiation, that radiation is receiving from all the galaxies at once. Got my point? So that was observed by the scientists in 1964, so Arno Penzias and Robert Wilson. Understand? And the next, in June 1995, scientists detected primordial helium in the four reaches of the universe, consistent with an important aspect of the Big Bang theory, that is a mixture of hydrogen and helium was created at the beginning of the universe. So that means the scientists found that this is primordial helium. So they thought of that when the universe starts with the two elements, one is the hydrogen and another is helium. So that's why we are Bohr hydrogen theory and then helium. So Sommerfeld, Bohr, these are all, they are striving to explain the hydrogen atom. Understand? So that is also one of the evidence. And then see, now I will tell you the Hubble telescope, how it come up with a good evidence. See, this is a starting point, and they are calculating the distance. They are taking it away almost all the distances. They are the Doppler shifting redshift. Understand? So this redshift is nearly 10 to 20 billion years ago. That is a 15 billion years. They are average, and then the spreading means it is a redshift. And to know the distance, rate and relative positions and all, then they are able to calculate a very simple formula, that is a speed into time equal to distance. Very simple formula, because we are observing our galaxies are moving away from that, how much speed they are having and then how much time they do take away in a particular time period. How much time will it take, and then how much distance they are traveling. Simply distance of the particular galaxy and the galaxy's velocity is equal to time. So that is nothing but, time is nothing but 4.6 into 10 to the power of 26 centimeters or 4.6 into 10 to the power 17 seconds. That is 15 billion years. Simply they are taking a 3 letters formula: distance, time, velocity. Velocity equal to distance by time. So time equal to distance into velocity. So that means particular galaxy, distance of a particular galaxy and that galaxy's velocity, they are taking it away, and then they are calculated. They are able to calculate nearly 15 billion years back, 14 to 15 billion years back. This was happened. Still we are in expanding mode. Still we are in expanding mode. And then next, these are the no standard model for particle physics, and search for God particle or a Higgs boson. This is a sensation. This creates a lot of sensation, a lot of curiosity among the scientist fraternity. Understand? So this God particle, that means search for God particle, is nothing but a Big Bang theory. Okay, search for God particle is nothing but a theory, and as well as a practical is there. A practical is a Large Hadron Collider that is there. And then the next one is extra dimensions. We are able to see only limited thing. We are not able to see dark energy, dark matter and other things. So we are able to see only 10 to 20% of this universe, and remaining we are not able to see. So that means, do we have an extra dimensions? Yes, it might be. Dark matter and dark energy, this is the next. And these are the 3 big questions. What are they? No standard model for particle physics, and extra dimensions we may have because we are not able to see all this universe, and dark energy, dark matter is one more thing. And how can we understand this dark energy, dark matter in this universe? And the next, these are the forces, and then electromagnetism is a photon, and weak forces is a Higgs boson, a Z boson. And strong interaction gluons, and gravity means the gravity is not yet quantized, no, you just see, and that last year only the quantized that the gravity waves are there. Higgs force is there, the Higgs boson not yet detected, that means they are detected already, almost all they detected, but these are not yet quantized, not yet detected. These are the curiosity questions. So how the gravity waves and how it existing, and then Higgs boson force, and that is the that is a particle which gives a birth for all other elements in this existing universe. Okay, so that's why we call it as a God particle. So how the God particle is formed, and can we recreate the early conditions of the earth? So now the question is, so can we create the early conditions of earth at time t equal to 0? Can we create that same situation artificially right now? Suppose if we create, then after 10 to the power of minus 43 seconds gravity force comes out, and after 10 to the power of minus 32 to 35 seconds, then it will be separating, and 1 second or 3 minutes, then the gravity separates, and the electromagnetic forces and all forces happening. And then can we create, or can we recreate the early conditions of the earth? Suppose if you do that, then you can have a chance to find what is the source of this all the matter for this particular universe. Understand? So this is, yeah, Big Bang appeared to various exotic physical phenomena that have not been observed in terrestrial laboratory experiments and incorporated in the standard model or particle model, and dark energy, dark matter are considered the most secure. And the next one is about dark energy, dark matter. I don't want to explain much more. This is extra dimension dark energy, dark matter, and these are the extra dimension explanation. And some of the string theory is also one of the theory they proposed by the scientists. And the universe at a glance, just see, the universe, what the universe today is 72% dark energy, 23% dark matter, 4.6 regular matter, and less than 1% neutrinos. Just see this diagram. Yeah, this is heavy elements, and this is neutrinos, and this is stars, and free hydrogen and helium, dark matter and dark energy. That means you are able to see only the visible. So this is that's why it gives you a spectrum. The visible matter is this much, and these are all, what is this? Invisible. So that means in this universe we are able to see only a limited, and that too a small portion of this universe. Understand? Understand or not? So this is, the universe today is 72% dark energy, you are not able to see, and 23% dark matter, and 4.6 regular matter, this is nearly 5%. I am telling you for 10 to 20%, it is not, it is just 5%, and remaining 95% we are not able to see. And the energy density in matter decreases with the expansion, energy density of the matter is decreasing with the expansion of universe, because universe is expanding mode, but the dark energy density remains constant as the universe expands. Therefore matter made up a large fraction of the total energy of the universe in the past, and it does today. So this is the thing. Then now this is the first part of Big Bang. So these are all the theory questions. What the theory? So that means there was a big explosion happened with an unequal amount of matter and antimatter, and the matter which is left is unequal part, and the matter drives with a radiation and all. So that means that is an annihilation process, you have a radiation. So that means that energy. So that means from beginning time t equal to 0 to now it is nearly 15 billion years, and then different stages, what the early conditions of earth and other things, and then we don't have a standard model, and we are expecting that 72% dark energy and 23% dark matter, and dark energy is 23%, and dark energy is 23, and dark matter is 72%. Only 4.6% we are able to see, and remaining we are not able to see, and most of the part is invisible in the form of dark matter and dark energy in this universe, we are not able to see. And do we have an extra dimensions? And these are all very curiosity questions. And one more thing is, during early conditions the gravity and electromagnetic and other nuclear forces, they are separating with a fraction of seconds, and shall we create or shall we recreate the early conditions of earth, and then how we are going to do this experiment. So this is the theory part. You have learned today's class theory, and then one more class is there. The next scientist comes with this theory is going to be tested with a gigantic experiment, that is a large hadron collider. And one more thing, why the humans on this earth got fear about this particular large hadron collider experiment, LHC. So that is the next part I will tell you. Almost all involved, in this world, the Large Hadron Collider is a very gigantic experiment, and then almost all the countries, they invested billions of dollars to test this particular Big Bang theory and to create early conditions of the earth and to know about the unsolved and resolved questions and dark matter, dark energy, extra dimensions, and God particle. Okay, this is a very interesting experiment, and the theory you have learned in this class. In the next class I am going to explain how far the scientists are succeeded to run this particular experiment, and what are the disadvantages of this particular experiment and all, we will discuss in the next class. Okay, thank you dear students. Do you have any questions? Okay, thank you.